I'd like to welcome everyone, all of you, each one of you to this webinar. It should be a very interesting one. And what we're going to be talking about in a few minutes is the CVE 2020-8554. And this is a critical flaw in the Kubernetes architecture and design. It's a security issue that affects multi-tenant clusters. And there's really no fix for it at the moment. So we're going to talk a little bit about that. And Manoj Ahuje is our presenter today. Manoj, if you move the next slide, please, and we can take a look at you. And there we are. Manoj is a threat research engineer with Tigera. And he's been with us for quite a while. He's actually incredibly expert at vulnerability research and malware research, and he's worked on a number of solutions that help mitigate threats in the Kubernetes environment. He's also had previous roles at Juniper Networks and Intel as a security researcher. And I'd like to welcome Manoj. And Manoj.
Thank you very much, John. So good morning, good evening, everyone. So today we're going to talk about this particular CVE, which is a critical flaw in a Kubernetes. So today's agenda is straightforward. So we will start with a CVE, what is it and why you should be looking into this. And we will talk about Kubernetes services and how they are tied to this CVEs. Then we will look at Calico Enterprise runtime defense, how we kind of natively prevent this particular CVE. And then we will talk about a live detection in cluster. So this is the agenda, and let's get on with this. So what is this particular CVE? Usually when you are in cloud world and you are running a Kubernetes cluster, your cluster looks something like this. There are multiple services in your cluster. So there is a front-end service which is talking to other microservices like your backend or something else. And those services are kind of letting users from internet talk to them. So what happens in this cluster is, let's say you have an attacker who has a privileges to create service or patch a service. So attacker can create this particular malicious service in parallel to your other services. And now he is targeting a particular IP. So here we showed 8.8.8.8, but it can be any IP, private or public. And once attacker creates this particular malicious service targeting particular IP, now any one of the pod from your cluster tries to go to this particular targeted IP, let's say .a on internet, rather than going to internet. The traffic is routed within the cluster to this particularly malicious service, and service is backed by a pod or a server. So basically a man in the middle server, and attacker can see what's the traffic. So this is really critical because all the Kubernetes versions are affected by this, and there is no fix in sight. Because if you want to fix the service creation, you need to fix how the services are created on the node, how the routes are injected into the host, and how entire L2 and L3 routing is managed. So I don't see any efforts in Kubernetes community to really work on this. So we don't see any fix currently. Other thing is all the Kubernetes services, service types are vulnerable to this. We will talk about these service types shortly. All the this particular vulnerability affects nodes and pods both. So the cluster pods are definitely affected by the routing issue caused by this service, but the nodes on which the pods are running, those are affected as well, because the service route injections kind of affect your nodes as well. And there is a huge risk to multi-tenancy, whether you are a public cloud or a private cloud, or you have a hybrid strategy in place. uh, if you are using a multi-tenancy model, or at least you are at least assigning a namespaces to various teams, and they have their own service accounts with various privileges. And now if one of the service account has create or patch service privileges, which usually, even if you follow principle of least privileges, they will have a create service at least. So you can a single service can bring down your entire cluster with this vulnerability. So, what are let's talk a little bit about what are the Kubernetes services affected by this. So there are typically three types of services, and each service type has a particular use case in mind by Kubernetes developers. So one is node port, where you want to use your node or VM instance IP for your service. The other is cluster IP, where you want to expose your service internally on private IP, and that IP can be routable within your cloud infrastructure, or on within your data center as needed. And third is load balancer IP. This particular service usually used to expose your services externally. And there is a horizontal to this, which is selectorless services. So basically you can create a service and associate an endpoint, which is again another Kubernetes construct. And this endpoint can be anything. It can be within your cluster or outside your cluster on the same VPC that your nodes are running, or this can be external IP. So what it means is your service can send traffic to outside IP. Here, I just highlighted on the right side that it could be a public IP. This is our dock side. So basically, service can redirect traffic outside the cluster to our dock side. So some of the misconception, as we see, there were particular use case which was in mind for each type, but you can essentially configure each of the service type to expose externally, and each of the service type can be used to target any public or private IP. Here you can see all the types have public IP, public cluster IP, and then there is an external IP. This external IP is basically you can patch it, or you can create a service with external IP, and you can target that particular IP cluster wide. So here, many people have misconception about this vulnerability, that it is dependent on a CNI, that is a cloud network interface, how the companies are implementing it. Yes, true, but in our experience, most of the companies that have changed the service implementation is towards load balancer IP or cluster IP, where they did a routing on a L3 stack. And if we just say that, hey, I'm not vulnerable to load balancer IPs, it's not true, because you are still affected by other service types which are implemented on L2 and L3 simultaneously. Let's say node port. Uh, so there were confusion about this CVEs, who is vulnerable, and it looks like even if you are a CNI and you are looking into networking really closely, you are looking at the network packets flowing in and out. You are vulnerable. You might not be for one of the service implementations, because how the CNI has uh, uh, implemented their stacks, but you are vulnerable to one of these vectors. So this diagram looks kind of too much, but if you look at it at the bottom, there are three nodes, and basically these three nodes is a Kubernetes cluster, and then on right hand side there is a fourth node, which is on a same VPC subnet as this other node, and on the top side there is internet. And there are essentially three use cases that I want to highlight that are possible with this vulnerability. So let's say you are a pod and you are trying to go out to an IP that is 4.4.4.4. And remember, the connection can be UDP or TCP, it doesn't matter. uh, you're just trying to go out to the IP, and once the packet leaves your pod, it will be intercepted at some point by malicious Kubernetes service that is created by attacker. And this service will have three options to reroute your traffic. Either the attacker can send this traffic within a cluster to attacker controlled man in the middle pod. That will be case A. Or he can reroute this traffic to a VM instance or a node on same VPC subnet, or he can reroute this traffic on internet, where the public IP is controlled by attacker, and he can see what's inside the traffic. So, so how can Calico Enterprise come into how Calico Enterprise comes into picture, and uh, how we defend against this vulnerability? So let me just paint you a really small picture here. So here on the top side, you can see a normal Kubernetes flow where you have a Kubernetes service, Kubernetes cluster, and attacker has created a Kubernetes service. So now your pod is trying to go out on this particular public IP 8.8.8.8. What happens is the Kubernetes service is nothing but a NAT service. It will look for those particularly targeted IPs and try to do a destination NAT on that particular IP and reroute that traffic basically. Then the routing will take care of the packet's path. So on top, the traffic is kind of intercepted by KH service, malicious Kubernetes service, and rerouted to attacker controlled IP. But when you have Calico Enterprise running, so what happens here is essentially you are going your pod, let's say, starts to has a command curl and go to this a.a.a.pod. So as soon as the traffic leaves the pod, we have a view into that traffic, and we can enforce the policy right there. And we say, hey, the destination is a.a.a.8. Is it allowed via my policies? And if yes, then I will let that go forward. And it will be intercepted by KH service next, and it will kind of do the destination NAT and change its destination IP to a attacker controlled IP. And at that point, as soon as Kubernetes service does that, we have a post DNAT enforcement in the Calico Enterprise, where it will again look at the packet and look at the destination, and it will say, hey, your destination has changed to 10.0.0.1. And this is particularly not allowed, because you are only allowed to go to 8.8.8. And this is how we kind of drop the packet, and your traffic cannot be hijacked with Calico if it is in place. So let's take this concept in mind, and let's try to implement this concept to or scale at the level the enterprise are operating. The Calico is known for its scale and running thousands of nodes simultaneously. So how do we secure your cluster? Your cluster may have thousands of nodes, thousands of namespaces. How can we do that? So we have something concept called tiers, and tiers are allocated team wise. So your security teams can have the highest tier, and then your ops team will have second tier, and your dev teams will have the last tier for your application. And policies are evaluated from left to right. So in the security team tier or infosec tier, you can just create your policies to protect against this vulnerability, or you can create your new tier somewhere in the middle, and just create the protections for this particular CVE in between. Another thing to note here, usually our firewall rules, usually in NGFWs as well, your policies are binaries. So once you hit a rule on the firewall, your policies are not uh, uh, they are not evaluated further. Once the traffic is allowed, it is allowed. If it is denied, if it is denied, you don't evaluate the another set of rules. But I think with Calico, what you can do is you can deny some allow specific traffic in the first year, and again in second year you can get a chance to filter it again, or apply another set of rules on that allowed traffic. So this is something we will take advantage of uh, for this uh, for this to protect against this particular vulnerability. So let's see how. So let's start with a simple use case where you we have a namespace and we want to secure that namespace, and this is particularly in perspective of multi-tenancy. If you have internal teams using namespaces, you can directly implement this globally on the cluster. But if you are if you are a tenant at some uh, in some means service, then probably you will have to implement it across your namespace only. So let's have a quick demo and see how the policies work. So hope you can see my screen. Let me just make it bigger. So I'm sorry about this cluster name. We have this automation in place. It chooses random names from the dictionary. So I have this particularly weird name cluster. So we have, let's say, let me just show you the namespaces. And we have two interesting namespaces here. One is default namespace and one is kubeproxy MITM namespace. So what we will do, we will create one, basically right now I have privileges to create and patch service. Uh, so we will operate in this way. So let me show you service. So this is a simple and straightforward service, and right now it is backed by this selector app echo server, and this selector basically is nothing but a pod controlled by attacker. So let me show you the pods running in the namespaces. So this is my default namespace, and we will be using crown pod. And let me show you the pods running in kube proxy namespace, which will have our malicious service. So we have this MITM pod, and what we're trying to do is we will try to send the traffic via crown pod, and we will try to, if the attack is successful, we will see the traffic is intercepted by a Kubernetes service, and it kind of hit this MITM pod. So let me just quickly exec into MITM pod. So on the top, I already exec into this pod. Hopefully you can see it better. So we will just run a simple command line server here just to listen for incoming connections. So now we have our MITM server running, and let's exec into our other pod, crown pod. So I have it already here. So let's clear it. Okay, so we are at the crown pod, and now what we'll do is we will kind of apply our malicious service. So simple command would be using kubectl. So I have alias in place, so I will just write k, apply f, and malicious service. And I have it configured right now. So get service, we will look at this service. So here we go. This is the service, and our, let me just show you maybe better so that you see. So we are targeting here 1.1.1 IP. So let's see what happens. So normally, if you go to 1.1.1, it wouldn't give you any proper response. So let me just show you. This is my laptop right now. So from laptop, if I do 1.1.1.1, I guess basically get 301 moot permanently because it doesn't have any pages running on or a proper website running on this particular IP. And now if we go to our crown pod, which is running inside our cluster, I just exected to it. So let's do a simple curl, and just notice here as well. So this is our man in the middle pod, and I just did a curl, and this particular request was intercepted by a man in the middle service, uh, which we have created, and this redirected our traffic to attacker control pod. And right now, the response I see is from attacker control pod. Though it seems like I'm talking to this particular public IP. So it is very easy to manipulate the responses, or even see act as a proxy for this particular IP. Okay, so this is something here. So how do we prevent this? Let's look at a simple policy, Calico policy. Okay, hope you are able to see. So what we are doing here is we are creating one lockdown tier, inter namespace lockdown tier, and inside the new tier, we are adding a network policy, and the network policy is really simple, right? So we want to secure our default namespace. Right now, this crown pod is running into default namespace, and it is vulnerable to this attack. And we are saying, hey, every pod in default namespace uh, will be allowed to talk to each other, and you will be allowed to talk to some IPs from the internet. So there are two egress action here, if you see. So first is pass to destination selector all. This means just you are allowed to talk to within the namespace. And then there is another egress action as pass. So it just says you are allowed to talk to some of the internet IPs. And this selector private is here nothing but a global network set that we have configured. So I will show it in a minute. And then there is a second policy, interesting policy here, which again locks down everything. This is the deny policy that we are applying on egress. So let's just apply this simple policy and see what happens. So we have created this policy, and let's see. Now if I try to go to 1.1.1, the attack fails because after post DNAT, as we've seen in the slides, the policy has intercepted the packets, and it has basically denied it, saying you don't have rights to go to 1.1.1.1. So this is how we can prevent it. So let me move to another part. Now that with a simple policy you can prevent this kind of attack, uh, is there a way? This is essentially a runtime defense, and once you apply these policies, you are protected against this particular vulnerability runtime. And it is equally essential to detect this attack in the cluster, or at least attempt to exploit this particular vulnerability. So we will look at the detection shortly. So let me show you how the policies look like that we configured. Okay, so earlier you see there were only two tiers. I just refreshed the page, and now I see kind of two policies here. One is locking down the namespace, and if you want to just look at the policy, I think GUI is much better way to see how the policies look like rather than command line. So you can see, hey, there is a pass action to all the endpoints, and there is a block action for uh, uh, means blocking the internet traffic. So let me go back, and there is a one more policy which is lock endpoint traffics. So in the slides we seen that you can create a particular endpoint, and with that endpoint you can take the traffic out of the cluster, because endpoint can be anything. So here what we can write the policies on resources, Kubernetes resources, and we just wrote a policy saying any new endpoint, any endpoint which is created, uh, the traffic to it will be blocked by default. So if attacker creates such service to take your or hijack your traffic and send it to external IP, by default he won't be able to, because your traffic to endpoint is already blocked. So if you have a real use case where you want to have a SQL server running somewhere and you would consider it as an endpoint, you will just need to whitelist that and you will be okay. So that's about policy. And let me move toward a detection quickly. So let's go back to our slides. So detection for this CVE is simple. So indicator of these attacks uh, are two things. So one is when the Kubernetes service is created or patched by a malicious entity, that is one of the indicator, and other indicator is when the endpoint is created or patched in cluster. So with Calico Enterprise, you can monitor, we monitor for many signals to detect different kinds of attack. And we put a signal for this particular CVE so that it can be detected. And since right now in the demo, we created one service, let's see if our signals have detected the attack by default. So let me just open the Calico Enterprise here. Okay, and this is a policy page. So let me go to the alerts. Okay, and once I go to the alert, I see two alerts here. So we created one service, MITM external IP, and that service got flagged. It is saying, hey, the endpoint was created for this particular service, and the details for that, where what is the resource that is the endpoint and what is the name of the service, and this signal tells you that this is a possible exploit attempt by creating a endpoint. And there is another one alert. Second one is saying possible exploit attempt by creating a service. So both the actions we have taken to exploit this vulnerability were detected by Calico Enterprise, and we were able to see the alert with high severity. So basically, we were able to detect it. So with this, I want to just summarize that for this particular attack, I think we showed you the runtime defense by Calico Enterprise, where we were able to look at the packet pre-NAT and post-NAT and enforce the policies on that. So you are secure by default if you are using Calico policies. And second is, if you want to see any attempt of exploitation or a successful attempt of exploitation, uh, you will be able to we will be able to monitor your cluster and detect this kind of malicious things that may happen or that can happen in your cluster, and alert you on that, letting you know that, hey, there might be a problem here in your cluster. So uh, this is it on detection. So let me go back to our slides. So yeah.
Awesome, Manoj. That was a fantastic demo. Thank you so much for sharing that with everyone. And that's certainly an ingenious way to handle that vulnerability, that unfixed vulnerability, that for a man-in-the-middle attack. So we are open for questions now. And while you're thinking about questions you might want to ask Manoj, we can move to the next slide. I just want to share some upcoming events with you. And you can see that we have on a pretty regular cadence, a couple of events, at least a couple of events every week. They're online, they're free. Many of them cover security issues as well as observability issues for Kubernetes, and they feature our technical experts here at Tigera. And just moving a couple of slides ahead, if you're interested in trying Calico Enterprise and getting a free trial, on the next slide we share some information about how you can do that. And on our website you can try it for free, and it handles a lot of automates a tremendous number of capabilities, and really reduces the operational overhead in your environment. Plus, it's very much focused on security and observability with the tools that are included. So we do have some questions here, and I'm going to get into those right away because we have quite a few. So Manoj, first question is,
Sure, John.
why is Kubernetes not patching this vulnerability?
So as I said, I think the implementation of the service is the uh, base of the Kubernetes, on which it is one of the building blocks of the Kubernetes. And one of the things happen here is how the services are created. That is, the routes are created into the host routing table, and then those routes are propagated into all the nodes. And if you want to patch this vulnerability, that basic behavior needs to be changed. And we really don't see enthusiasm in Kubernetes community to kind of change this fundamental building block of it. So that's why this our assessment is this vulnerability will be unfixed for some time, because we really don't see any enthusiasm from community to fix it.
Okay, thank you. Next question from our viewers is, is the vulnerability dependent on the CNI? Or I guess another way to put it is, does the CNI have any impact on I guess the effectiveness of the vulnerability?
I think definitely. I think the most of the cloud network interfaces, those because Kubernetes is a flat architecture, and if you want to secure Kubernetes, you need some kind of cloud network interface. So Google has their own, AWS has their own, AKS has their own. So I think everyone knows the Calico is one of the topmost. And how we do the networking is we implement these network stacks in our own way. And uh, with each and similar to us, other CNIs do that. But most of the times the CNIs have implemented one of the service stacks, and they just looked at that and said, hey, we are not vulnerable to this particular service type. But what essentially we need to do is look at the all the vectors here, that are all the services, three services, and you need that fundamental building block secure on all these three vectors. And what we have seen is many CNIs didn't do that.
Very good. Thank you, Manoj. And there's another question here. I think it's well, a couple of questions. I think they're related. Can the
Mhm.
policies dynamically be implemented in code? As a GitOps, and if so, are they able to also automatically scale as the size of the cluster increases?
Yeah, I think that's a good question. I think with API driven policies, it is really easy to add these policies into your GitOps, your provisioning scripts, or if you have any CI/CD automation in place, you can just put your policy while creating your clusters, and these policies will be present securing your cluster by default from the day one of your cluster. So uh, and other thing I want to just point out here, these policies are highly scalable. They work on thousands of nodes and tested by industry. So we can definitely rely on them.
Excellent. Excellent. Okay, well, that's great. I think we're good with questions. And once again, I'd like to thank everyone for joining us this morning. Thank you, Manoj, for an excellent presentation. This webinar has been recorded, and if you were unable to join earlier or you just want to review it at your leisure, just please go to our website, www.tigera.io, where it will be posted on your events page. So once again, thank you everyone for joining us today.
Thank you, everyone. Thank you very much.